Let's take a look at how to determine the molality concentration of a solution. Molality is similar to molarity concentration of a solution, but it's slightly different. Molality is very important when you're studying the colligative properties of solutions. Okay, this is when molality will be most important and utilizing its value. Okay, is when you're studying colligative properties such as freezing point, boiling point, osmotic pressure, vapor pressure of a solution. Okay, those are physical properties that are directly influenced or changed by the amount of solute present in a solution, by the molality of a solution. So I want us to work with molality for a couple of minutes. Okay, molality is equal to the moles of the solute. Okay, now moles of solute. Solute is the substance that is being dissolved. So if you're mixing sugar into water and dissolving the sugar would be considered the solute. So it's moles of solute divided by the kilograms. Okay, notice that's a mass. Kilograms of solvent. Okay, so in our sugar water example, the water would be the solvent. The sugar would be the solute. Okay, so here is an example for you. We have a solution and we have dissolved 12.2 grams of iodine. Okay, the element iodine, 12.2 grams of iodine, in, we have it in 100 grams of carbon tetrachloride. Okay, so one to use different elements, different compounds than just a water aqueous solution here. So we have 12.2 grams dissolved in 100 grams of carbon tetrachloride, and we're going to determine the molality. Okay, molality, you'll often see it written as a lowercase m, kind of a italicized or a curly tail on the m. Okay, so we have our solute is the iodine, and our solvent is the carbon tetrachloride. So let's get this set up. Okay, so molality equals, okay, so we need moles of iodine. Okay, so we need to first change this 12.2 grams to moles. So we remember that 12.2 grams of iodine. And how do we change things from grams to moles? We divide by their molar mass. Okay, and the molar mass of iodine, I2, we just reference our periodic table and we get the molar mass of the iodine. So iodine is 126.9 and it's a continuous, rather lengthy decimal. So the molar mass is 253.8 grams of iodine per mole. Okay. So let us remember, when we're converting grams into moles, we divide our grams, our mass sample, by the molar mass of the substance. And then we will have our moles of iodine. Okay, so moles of I2. And then we have 100 grams of carbon tetrachloride, our solvent. We need to change that to kilograms. Okay, so we remember from earlier in chemistry, 1 kilogram is equal to 1,000 grams. So we have 0.1000 kilograms of carbon tetrachloride, which is our solvent. Okay, so we have 0.1000 kilograms of CCl4. Okay, so now to get our moles of I2, we just do 12.2 divided by the 253.8. That'll give us 0.048, and let's have one more decimal, 1. Okay. Moles of I2 divided by the kilograms, which is 0.1. Okay, make sure that you use kilograms. And we get a molality of 0.480. And the unit for molality, we just often put this lowercase m with a slight curl or italicized look to it. And that is our molality. Okay, so molality is moles of solute, which is the substance being dissolved, divided by the kilograms of solvent. Okay, so moles of solute per kilogram of solvent, and it'll be utilized when you're determining colligative properties of solutions.